Hi all, my name is Brenda Crespo Perez, and this is my Teach One presentation on Causal Network. This presentation was prepared as part of the HAP 823 course taught by Dr. Farouk Alemi and Dr. Ronald Woodeman at George Mason University, Department of Health Administration and Policy. We will be going over week 6 and 7, question 5. Question 5 reads, inside an electronic health record, there is data on outcomes of a particular intervention. Using the network drawn, write the equations that would allow you to estimate what would happen if the intervention was not given. This question is broken up into two parts. The first part asks us to write an equation for each node in the network based on variables that precede it. The second part asks us to set the variables that change across these equations to the relevant values. For example, set treatment to be 0. Before jumping into the question, I'd like to quickly review the causal network provided. As a recap, we know causal networks are directed graphs. There are various parent and child nodes or relevant nodes in the network shown. We can see that severity of illness is a parent node of do not treat preference, intervention/treatment, and adverse outcomes. As a side note, we see that random chance is included on the bottom right as a parent node. This is the error term, which indicates the unexplained variance within the model, and we will be including it in our equations. So we will be using a regression equation because it allows for understanding of relationships among variables. Each component in the equation is broken down and detailed on this slide. You see the overall constant as alpha, regression coefficient or slope as beta, and error term as E. Now to answer the first question, we're going to write equations for each node in the network given. Here we are writing an equation for severity of illness, which is a fairly simple equation because it has no parent nodes. Severity of illness equals alpha, or its y-intercept. As a side note, I labeled severity of illness as beta sub 1, so it could correspond to alpha sub 1. And I use this standard in the equations that will be shown in the upcoming slides. Here we see provider's decision, which is another root node, so it will be fairly similar to the previous equation, being provider's decision equals alpha. The next node we're going to look at is do not treat preference, which is labeled as beta sub 3. The overall equation is do not treat preference equals its y-intercept plus beta sub 1, or severity of illness, which is the parent node. Next, we have intervention/treatment, which is labeled as beta sub 4. The equation for this would be intervention/treatment equals its y-intercept plus its parent nodes, being severity of illness, do not treat preference, and provider's decision. The final equation in our network is for adverse outcomes, which was given as an example in the question. The equation reads adverse outcomes equals its y-intercept plus severity of illness plus intervention/treatment plus random chance. Now that we completed the first part of the question, we move to the next. The question asked to estimate what would happen if intervention/treatment was not given. I found that there were two examples when intervention and treatment is set to 0. In this first example, adverse outcomes are mainly due to random chance, or E. The equation states adverse outcomes equals its y-intercept plus beta sub 1 plus beta sub 4 plus E. When beta sub 4 is given a 0, it then cancels out and leaves alpha plus beta sub 1 and E. Also in this instance, you see that beta sub 1 is also given a 0, which then cancels out as well. So the end result is adverse outcomes equals alpha plus random chance. In this second example, we note that adverse outcomes are due to severity of illness and random chance. The same equation is used from the previous slide, and intervention/treatment is set to 0, as you can see in the second line. The one concern was the question didn't really specify how severity of illness was categorized. So I set the value of severity of illness as x. So the final equation reads adverse outcomes equals its y-intercepts plus beta sub 1 x plus random chance. And with that, we are done with question 5. Thank you for watching.